how we roll, man. Some rock, some win, some 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 win.
Hi, my name is Loris Crow, and we are executing at Showtime. Zig Showtime is the show where members of the Zig community come on stream to share coded ideas with the broader public. Every episode features two speakers who will present and take questions from you, the viewers. Zig Showtime is not just what you're seeing on the live stream, but also the discussions that you can have while watching, and that's why I encourage you to join one of the existing Zig communities that you can find by going to ziglang.org. So, hello. We are, I think this is episode number 14. I see that there's a nice group watch team of people in voice chat in the Showtime Discord server that are chatting with each other. So just putting this out there, if you are interested in this type of experience, consider trying it out. I think it might be fun. I don't know. I usually am here hosting it, so I can tell you firsthand how is it on the other side. But it does seem fun. Okay, so let me see. What news do we have? First of all, I think that the Plushy interest check from Nipsey is still open. So if you can get your hand on a link, which maybe he can, wink wink, paste in chat right now, or you can also find that by taking a look at the Zig Showtime newsletter. Just go to zig.show, and then from there you can find the newsletter, sign up, or even find the archives online. And you can fill the form and show your interest in buying a Zig plushie for either Zero or Ziggy. And here's the link. Yes, thank you, Nipsey. And also thank you, Sob, for the subscription. Thank you very much. Oh, Prime. Oh, even better. Thank you very much. Hey, Caleb. So, thank you for the gift. What was I saying? Oh yes, so there's the Zig plushie, which is interesting, but there's also a second news that I wanted to share today, which is about the work that I'm doing with the website. So let me switch to that view for a moment. And I want just very quickly to give you a short demo about what I'm doing with the website. So as you know, we have the Zig website, ziglang.org, and I'm working on the redesign. I've done some work looking at what other programming language websites are offering to see if there's any good idea to steal, or what's the general language that, like languages in communication language, visual language, structural language that other websites for programming languages adopt. And after that, I wanted to take a look at the tooling to see what type of things the tooling will be able to support, because the reality is that you like the range of things that you can do at the end of the day depends on the practicality of the tools that you have and the amount of effort that then you have to put into stuff, and you have to decide how to use your effort. So the better tools that, you have, the more things you can achieve with the same amount of effort. That's the idea. So in terms of tooling, what I did was basically take a look at so right now the ziglang.org website is just HTML, and I wanted a templating language because one of the things that I think we should address is internationalization. I think that would be very useful to tackle since the beginning. Also considering that we really are a very international community. Oh, oh wow, thank you. Thank you, Iridescent Rose, for the gifted subs. Thank you. I forgot that I have these views enabled on this scene. So, so the idea is let's tackle internationalization right from the beginning, but we need tooling to do that, right? If we just have HTML files without any templating system, doable, but requires more effort than it would otherwise. So I took a look around, and for now, I'm thinking that Hugo which is a static website generator, is the right tool for us. At the beginning, I know we're not dog fooding any Zig technology directly, but we can get there in the future, right? We can substitute Hugo in the future with another tool. We need internationalization first before it's more important to have that today on the website rather than wait for a Zig tool to show up and do that for us. So let me show you what I have. Yeah, basically what I did is re-implement the Zig website in Hugo one-to-one. So the idea is re-implement everything in Hugo, swap the implementations, and then start making incremental improvements on the new implementation of the website. So the website is meant to kind of look the same, but it has a few features more. And what I want to show you is also this. I have this Hugo server that Hugo is a single executable, which is nice because then you can chuck it on the repository and have it run the static website generator from the CI without having to like download dependencies and do other weird stuff. And when you launch it, one thing that I did is that I integrated Hugo with the Zig DocGen, which I think would be better named as like doc test system, where basically we have these samples that are, here's the markdown file that has all the intro, all the stuff that you were seeing from the homepage, that you can see on the homepage of the ziglang.org website. And all code snippets are saved, are written down as this, let me see if I can zoom in. They're saved as these tags here, Zig DocGen, and then I point to a file. And these files are in here, where they are using the syntax that the DocGen tool from Zig uses. And these are code samples that get actually tested against the Zig compiler. And these tests are not just checking the syntax, but they're also running and like tests that should fail. Hey, SlimSag, thank you for the follow. So tests that should fail, they have to fail. If the test doesn't fail in the precise way that it's supposed to fail, the whole website generation process fails and an error gets reported. So this is nice also because this is also integrated with the caching system where if I, for live development, it's nice also to be able to change things, right? So let's say that here, I want to change, I don't know, let's change hello world, and I want to say hello Zig Showtime. I make it change, I make the change, I save the file, and then if you go here, oh, right, it's not watched yet. I have to configure watching in there, but let me change a small detail also on the main page. I'll add a hello here. Doesn't make sense, but this triggers the regeneration, and you will see that all are cached because nothing changed, but the one that I did change, hello.md, is being retested. So if you make a change to the syntax and the syntax doesn't compile anymore, doesn't match, you get not you see it because everything is really tested for real. And this is not something I implemented. This is from Andrew, and it's just the it was already there. But it's nice to have this integrated with the main system. So what did I want to show you? I wanted to show you that this basically, Hugo, it's a tool like any other. I think it does a good job in general at separating the layout from the content. And we already have like a few translations available. For example, the sponsor, the Zig Software Foundation page, which is saying 404, interesting. Let me try in English. Okay. Did I delete the page? I don't think I did. DSF. Oh man, this is embarrassing. I wanted to demo this part, but did I break it for some reason? So ZSF, index, English, Italian. Oh no, I'm being betrayed by my own system. Hey, thank you, Matt, for the gift of subs. Oh man. So, oh no, I wanted to demo this. How did I break it though? That's embarrassing. News. So news is working, but somehow I broke the ZSF. part. Okay, I'll have to take a look at this. I probably misconfigured something when I was touching it last time. But we have all the different pages. So if we are in the home, we can also do /IT. And it brings us to the Italian version of the website, where the homepage, I don't have yet translated the whole introduction, but the main menu structure has been translated, and we have the German version in the Hey Siphon, thank you for the follow. So we have the German version that has been contributed by Felix. We have also a Polish version that was contributed by Nyayan in also, who is in on Twitch, and that's nice. That's really nice because these translations are very easy to contribute, and that's thank you, Nixie, for the gift the sub. And these are all nice things that we can have on the website with not much effort. So, sorry, this took longer than I wanted it to take, but it's just a demo of the things that we have. And as I said, the idea is take small steps, just make sure to do the right thing, never waste effort. So, re-implement the website on Hugo, swap the implementations, and make small changes. Another thing that I should say, thank you, Felix, for the gifted subs. Well, guys, what's happening today? Thank you, everyone. Thank you for the follow. So, what I wanted to say is, this is the part of the job that I'm doing by myself. I'm making decisions by myself. Obviously, I'm open to discussion, and if somebody has other opinions, for example, somebody also recommended other. Sobson, you weren't a follower? What's up? Thank you for the follow, I guess. About time. So, these are decisions that I make mostly by myself. If you are interested, please, well, you can follow the stream when I'm doing most of this work live on Twitch and chatting with people as I do it. I also have a dedicated channel in the Zig SHOWTIME Discord where I'm discussing it with people there, the changes that I'm making. But once this part, which I think is where I think I want to have I don't think there has to be a bigger consultation with the community at large. Once we start talking about the actual redesign, I will open the process a bit more, allowing more people to get insight into it and offer their opinion if they want to. That doesn't mean necessarily that that this should be a design by committee. I don't think that's the case. But I'm far from perfect, and I'm absolutely looking forward to have input from people that know better than me, at least in specific domains. Okay. So sorry, there's Jakub in in standby. Sorry, he's been waiting for a while now. Okay, let me switch to the first talk so that we can finally start. Here's the title. Okay. So. Jakub is back again with another talk. Last time he talked about WebAssembly and more specifically WASI, but this time he's going to talk about MachO, the Apple executable file format. He went from working with a documented and open API to wanting to witness firsthand how Apple thinks differently when it comes to API and documentation. Jakub? Sorry, the talk is Introduction to MachO, Linking and Zig. Jakub, the stream is yours.
Cool. Hey guys, can everybody hear me? Yeah, is everything okay, Loris?
Yes, absolutely.
Cool. So yeah, I actually changed the title. I changed it to exactly what Loris specified in the email. So this is harvesting MachO energy for badness. And as Loris said, it's quite shocking how underdocumented MachO is. If you manage to find any docs that's officially released by Apple, the latest you're gonna get is from 2007. No kidding, that's like 13 years ago. So so yes, I had to browse through a lot of blog posts. Obviously, I went through the Linkers and Loaders book, and everything ended in reverse engineering anyway. So yeah, it's been fun. Today I'm going to talk briefly about the exciting stuff that's actually happening in self-hosted compiler. I will actually touch a little bit more about the architecture there, not only about MachO, just to show you how it actually works. And hopefully I'm not going to bore you to death, because this is quite boring stuff if you look at it. So this is what you can see in front of you. This is the I guess the traditional approach to linking that we have in C and C++ predominantly, but also having Rust. This is basically what LLVM does with LD as well. So basically we have source code going to the compiler, we generate some object code, and this gets linked by some generic linker into an executable or a shared library or I don't know, an archive. Then this gets fed into the loader, and that put into the memory on your machine. So this is a very traditional view. Everything is dependent on the object code. I think in C or C++, they were called compilation units, but I'd be wrong here. I'm not an expert. I think Loris will know more about this stuff. Oh, by the way, you should have read his and Andrew's amazing blog post about the advances in stage 2 compiler. So this is what we have. Now this is what we're trying to achieve in Zig. We decided, well, I guess Andrew decided, and this is a very good idea, to put compiler and linker a little bit closer together. So this is what we call tightly coupled. And basically with Zig, we do have an opportunity to actually generate an executable directly from the source code. So we don't actually spit out any object code before. And the same will be true for shared libraries, but we also will try to support the traditional view as well. So there are a couple of advantages here. The main one is that we can actually optimize a lot for Zig. And this is what Loris and Andrew were describing in the blog post. So what that will mean is that we'll be able to do incremental linking. And then hopefully in the near future also, hot code loading, was it? Swapping, I can't remember what the proper phrase for this was. So the good news is you can actually experiment this stuff on Mac already. The incremental bit works. There are a couple of well, bugs, I guess deficiencies you could call them, but this will hopefully get weeded out soon enough. Right, so now on to the meaty bit. So what's MachO? What does it do? Why is it so broken, and why is it so annoying? So basically, oh, by the way, I'm going to talk mainly about the executables. Objects are slightly differently structured. I mean, the general structure is pretty similar, but there's just one segment, and I'm not going to go into that yet or today. We're just going to focus on executables instead, because that's what we can actually generate with stage 2 for simple Zig sources, right? Like simple hello world or something. So in general, what you're going to see if you dissect the generated MachO file from stage 2 is that we're going to have 4 segments. The first segment always has to be so-called page 0, followed by text, then data, and then link headed. Text always has to be right after page 0, but data and link headed, I think they can be swapped out. I didn't experiment this yet too much, but I'm pretty sure you can actually swap them out, and it's going to be fine as long as you remember your offsets. The important thing to remember here is that segments are mapped into memory, and they have to be page aligned. So that's 4 kilobytes in both virtual memory addressing and also file offsets, and that's for performance. The only exception is link headed, because it's the last. Well, in this case, it's the last segment in the file, so you can actually not have it perfectly aligned for kilobytes. In file offsets, obviously, in virtual memory has to be. Okay, so every MachO executable starts at the address 0. On Mac, everything has to be relocatable. There's no way to actually specify like global addresses. So basically, you're never guaranteed where your executable is going to land in memory. Dynamic load, the DYLD can just basically put it anywhere, or even just take it out and then put it in a different address. Okay, so page 0 segment. A little bit about this. This might not seem as very important, but it is if you don't set the page 0 to be 4 gigabytes in memory, in virtual memory, Dynamic Loader will kill your application, just like this. It won't even care. It has to be 4 gigs. So it always starts at 0 in virtual memory. It's 4 gigabytes. And it's actually, when it comes to file offsets, it's 0 bytes. It makes it a little bit tricky when analyzing with like OTool or MachO view, which I will show later on, because because we're addressing 4 gigabytes, we're already starting at insane hex number. But you can get used to it, right? I hope. So the next thing is the text segment. So this one always starts after the page 0. So at 4 gig, it has to be page aligned in virtual memory and in file for performance. What else? Yeah, so in memory it starts at 4 gig, as I said. When it comes to file offset, it starts at 0. This has interesting repercussions, which I will get back to later when I will show you the header and stuff. Oh, actually, I've got it here. Right. So it actually contains the MachO header, load commands, and obviously the compiled machine code. So that's the read-only bit. Now, this is very annoying because of the way we have the code generation, the linker built up and designed in Zig. Andrew designed this really clever way of actually finding free space for different sections and segments in the file. And because MachO has got certain rules that have to be followed, like this one, you have to guarantee that the text segment is the first one actually spans in file from 0 onwards. So currently, I hacked it in the way that it gets created first, and you set the alignment to be for KB. So actually, we'll stretch enough, but this has to be reworked. So okay. So moving on, this is what the header and the load commands look like. So we have the MachO header. It's feed FACF. That's the magic number for 64-bit Intel MachO executable. It used to be feed face, as far as I remember. That was for 32-bit, which had a nice ring to it. So then we follow with load commands for segments. Those are LC segment 64, but that's not really important. It's just a technicality. We have things like LC SymTab for symbol table and so on and so forth. And then finally, after we have all the load commands and some padding, we have
Jakub, sorry. Sorry
to
interrupt you. I think we lost your desktop.
Did you?
Yeah. In this last slide. I refreshed the page, but I don't think I'm able to.
Right now?
To find you.
Anything?
No, I think you have to.
Okay. Let me
redo the
relaunch it then.
Yes. Sorry for the interruption.
No, that's okay.
Okay, let me.
Wait, high quality again.
The desktop. Sorry, everyone.
So where did I lost everybody? Oh, I have to wait. Copy. That's the third link, by the way, Loris.
Okay. These two.
Any luck?
Yeah, it seems to be working. I wonder why it likes to corrupt a little bit, though.
Corrupt? What do you mean corrupt?
Yeah, the static image bugs out a little bit in the corners. I don't know. That's an interesting bug.
Okay, so where did I lose you guys? The text segment is. Did you see that?
Yes, we did see. Yeah. It was just the slide that you were in, the last one.
Okay, cool. Okay. Yeah. So right. So come back to it. The text section. That's where we put the generated machine code. So the bread and butter of your executable. I got some trivia here written down for you. If you use something like OTool or MachO view or something, you're going to be presented with this glorified star address, which is the symbol VM address, and then the symbol name. That's basically taken from the string table, and then disassembled machine code back to the assembly. Okay, so right, then we have data segment. Traditionally, you would have things like C strings, data arrays, things like this. In Zig, this is very interesting, and this actually took me quite a bit to get my head around. We actually will create a global offset table and put it in here. I'm going to get to what it actually is. It's not a global offset table in the standard sense. It's much cooler. So we're going to get back to this. Again, as with all the segments, everything has to be page aligned. And then finally, we have the link edit. This is like this unwanted child of MachO, I think. I don't know. I don't know why it's got so many quirks. So this basically contains everything that you need to pass to the dynamic linker to actually for it to load the program into memory and execute it. And if you forget about something, then you're screwed. So it's highly underdocumented. It doesn't actually have any sections. So basically, when I was showing the section, like the text section, what you would normally have, how you have the load command for the segment, and then underneath it, like embedded, you would have any of the sections that you actually have within the segment. But with link edit, you don't have sections. You have other load commands that are sections. Bizarre, difficult to work with, but hey, this is what it is. So, right, to the cool stuff. So how do we actually link in Zig? And this is in stage 2. I'm not talking about the LD or anything like this. So given some generated machine code, and this is what's actually happening in, if you go into the Zig source code, that source, link, and then MachO, similar stuff is actually happening in ELF, just that it ends up in different bits in the ELF executable. But the general structure, I think, is pretty similar. So what we do, basically, when we get generated machine code, we get or generate, create index into the symbol table, which we'll use to reference that in the future. And then we also create an entry in the global offset table. And the entry in the global offset table is, surprise, surprise, the address of the symbol. So basically this, if I get it right, this is basically what makes incremental linking in Zig this much easier than what you would have if you were working with LLD or anything, like any of the traditional linkers. Because if anything changes, and I'll demo that stuff later on. If anything changes, then basically you update the offset in the global offset table. You don't have to actually shuffle around everything, like all the sections and things like this. Okay, so in this case we have, for example, if main was under the address of 3FO, obviously at 4 gig, then we would have it in the Landian order in the global offset table in the GOT section of data segment, right? Okay. So moving on. So this is a tiny example of actually what it would look like if you were to write out basically printf using syscall assembly on Mac. So Mac has got this weird, or maybe not weird, some people say actually clever way of addressing, or actually numbering syscalls. In this case, this massive number, which actually, I don't know, how much is that? What is this? It's like 2,000,004, I think, something like this, isn't it? That's the number for write. Basically, then we have which file descriptor we want to write to, which is 1 for stood out. And then we're gonna have a pointer to end the standard way, which is basically the hello world here, and then the length of the string is 14. Okay, I'm clobbering. I think memory is the only thing. I think as far as I remember reading on macOS, you don't actually clobber anything else. So then this gets generated, and I'm actually going to show that as well. Hopefully, we're going to have time. What happens here is that we generate this opcode here with this fancy looking address. This address actually taken, I think, from an actual example. So bear with me here. And what the hell is it, right? It doesn't look like what you would, I guess, expect from, let's say, LLD. I think in this case, you will basically be loading a C string from data section. But in this case, we are actually pointing to something. And this address is the address in global auth table, which then in turn points back into the text section, which will hold this chunk with hello world in it. So hello world does not end up in the data segment. It actually ends up in the text segment, which for some, I guess, might be bizarre. I mean, it took me a while to actually get my head around this. So we put all the text blocks, I guess you can call them, and actually I think this is what we call them in code, in the text segment, and then we refer to them via the global auth table in the data segment. Okay, I know it sounds a bit scary, but actually isn't, and it's really smart. And it works great so far. Okay, so, right, cool. I can actually show some stuff now. Can you see this? It's probably too small, is it?
Yep, maybe a little bit bigger would be better.
Okay, cool. Where? Voila. Yep. Okay, cool. So, as I was saying, this is basically this is the bit of the code. Well, part of it I was actually showing to you, the print bit, which starts in line 8. We have print and we have exit. Exit also has got a funky number for the syscall and Mac. This is not, I guess, what we would expect on a macOS because we are linking into lib system, which is basically the libc on macOS. But I'm pretty sure we don't have externs working yet in stage 2. Plus, I didn't get my head around how to actually do this. So basically, this is the same way. We test MachO the same way we would test ELF. It's just that obviously it's adapted to the way that macOS expects it and stuff. So having this bit code here, what I'm going to do, and I'm going to show it to you, like I think Andrew was showing in one of the videos at some point. So I've already got stage 2 pre-built, and it's going to be with logs enabled for linking stage, just to show you how it works. When it comes to the incremental linking, I think we can actually squeeze out a lot more. Currently, we are overwriting a lot, like regenerating a lot of sections and stuff, which we don't have to. But I didn't get to that part yet. We can actually store some offsets in a smart way and actually only basically update some bits, like symbol table or something, or the lc symtab load command. Right. So we have Zig here, and this is freshly compiled stage 2 build from. Oh, we don't have version. Right. So let me build the exe, which is the hello Zig, but let's do it incrementally. So this was the first build. And just to verify that it actually works, let me go to examples. Okay, we have something here. Cool. Let's run it. We have hello world. Cool. Now, let me edit source file. So for example, for testing, I actually like to stick in error code of 42, because that's the best number in the universe. And then we're just going to do update. And as you can see, actually, let me scroll back up. In the first instance, we had a lot of stuff happening. We've been allocating symbols, writing obviously the offset table entries and so on and so forth. And then in this bit, as you can see, actually, we don't do that much stuff anymore. We did generate a couple more symbols like exit, anonymous 9, 10, and 11, but there wasn't that much more. And let's see if this actually worked. So now what we should get here, okay, there was an error code. Let's get it out. 42, perfect. So let's have some more fun with this. Right. So we can actually print twice, right? That should be cool. Let's go back up. Okay, we're actually updating even less now. Perfect. So now what we should expect is actually hello world printed twice. Awesome. So this is exactly what I think Andrew was showing on Linux. And guess what? You can actually experiment this on your Mac as well. That's +3, which is what, 17, I think. Arithmetic is awful. Right, update. Oh, right. And this is what I meant. We actually do a lot of overwriting here, but I'm pretty sure we are regenerating some of the text block symbols. Cool. So this bit already works, which is great. As I said, there is a couple of things that should be ironed out before it's ready for some serious testing. I'm pretty sure it's not even ready for testing yet. The good news is we do have some basic tests in Zig already. So basically, whenever you tweak something, the incremental linking will get tested. Okay, right. So let me get back to, before we get on. So if you're on a Mac, there is this cool utility called MachO View. It's like this nice graphical user interface on top of Auto. So you could normally, well, if you feel like it, you can basically you can run Auto on a MachO binary to actually print, for example, the load commands and things like this. I actually can't remember how you disassemble. I think it was DV. Maybe not. Give me a second. Oh, right. So these are all the symbols that we actually have in the text section, including the actual print with, I should probably turn them into knobs. I didn't get time, like I didn't have time to do that. Yeah, then we have exit as well. Well, here, and then we have, up to here, and then we have some, well, should have some knobs as well. And the same thing, you can actually see in MachO View, but just in a nicer, format. Okay, we have the header, we have load commands. Oh, and I was telling you guys, so basically this is what I meant about sections being embedded within segment load commands. So we have the text section where we actually put all the assembly or machine code in. We have the section for our global offset table. And then guess what? Well, linked never gets any sections. But what you get instead is like all the other load commands that are like de facto sections for the link editor, which is bizarre, it's stupid. I don't know why anybody would create this. This is ironically, this lc load dilib load command is quite important, and this is what we're missing. One of the main things that we're missing from LLD to be able to cross compile to macOS from any other operating system, but LLD doesn't do that. For some reason, you would need to specify manually they want to link against lib system, so L system. But then again, if you're not on macOS, LLD will crap itself saying I can't find it. So need to wait a little bit, I guess. Okay, cool. I guess we can. Oh no, right. One more thing I'm going to show you guys. So I've got a little Linux box running here, which has got. So this is on Arc, and we have, and this is on Intel as well, with some relatively new kernel. So what I'm going to do here, I'm going to show you that actually I wasn't talking crap. Well, I am talking crap, but not, I wasn't lying at least. That you can actually generate the same stuff and Zig on Linux, cross-compiled to Mac with our stage 2, and it's going to be fine. So that's hello Zig. Target 4. Okay, that looks promising. So cool. So now let me very quickly grab that. What did I miss? Really? Oh, crap. Sorry about this. So we have the hello cross. Oh. And if we run it should run, and it does. And if we're going to open it here, you will see that the thing that I was pointing at, which is the yeah, there you go. See, so we actually do insert it, and this is what if you were following the conversation on GitHub, this is what Andrew was saying, that it's pretty cool because we are already one step ahead of LLD because we do allow for cross compilation from the start. Right, so I can get back to slides and talk a bit more about some other stuff. Right, so it took me quite a while to figure out what the minimum number of load commands and sections is for the MachO executable to be actually loaded properly by DYLD. And it turns out that one crucial bit, which is also very well documented, it's quote unquote, right? Ironically, is the export info. And what I mean by export info is actually export try. So basically in link headed segment, we need to put in some information for the dynamic loader to tell them exactly what we're trying to export here. And for executables, well, the small executables, that should be pretty easy because we export either start or main. At the moment, actually, if you try to export main, the linker will not work because we have it hard coded for start. Anyway, there's only one symbol. There's one trick. Well, actually, but when I was porting the export try to Zig, I thought that we should have a proper export try generation algorithms in place because this will be needed for shared libraries as well. And it's better to get it right 99% from the start than to get something hard coded in first and then work our way backwards. So the cool thing about this, and this is also the very tricky bit, is that the export try that the MachO expects or the DYLD expects is actually so it's a tree structure, it's a prefix tree, but it has to be serialized and ULEP 1 to 8 encoded. And this actually makes it quite tricky to do. So basically, okay, right. Before we actually get on to serialization, I'm going to show you basically what the try looks like. So we always have the root. Then let's say we insert symbol mh execute header. If you start dissecting MachO executables, you're going to see it quite a lot, especially if you use something that uses LLVM underneath or LD, DYLD? No, LD, I think. LD64, can't remember, on Mac. And as far as I know, this symbol allows other programs like debuggers or maybe something else to actually access the MachO information. We currently don't insert it, but we probably should. So we insert it. We only have one terminal node where we insert it with one label, which is basically the entire symbol. Then we want to insert main, and we do this clever trick here. This is not like the export try in MachO is not, I guess, like the simplest try you would get in your computer science books, because we don't, we basically compress the labels as much as we can. So instead of them being like characters, we actually have entire strings as labels on edges. So then if we insert main, we actually split the underscore from the previous label. We insert a node inside, kind of splice it. This becomes a non-terminal node, and from this node we have two children, which is the one underscore mh execute header, and then we have main. So far so good. Now, before I show you the serialization bit, we need to go very quickly through the ULEP 1-to-8 encoding. As far as I know, this is pretty common in debugging, writing the debugger information as well. It stands for unsigned little endian base 1-to-8. So if we're given this number in hex 765, that's what we get in binary. ULEP 1-to-8 encoding is pretty straightforward. What we do, we pad it until we get a multiple of 7 bits. So in this case, I think it's 14. It should be 14. Then we split into groups of 7. Then we set the most significant bit to 1 except that group. And basically, this is what we get. That's the ULEP 1-to-8 encoded 765. And this is quite important because, well, export try, I think except for one information, is everything else is ULEP 1-to-8 encoded, which makes it perfect, as you'll see in a minute. Right, so let's say we're given this export try. This is also, I think, one of the tests that we have in Zig for the export try itself. This is what basically the encoded values look like without padding. So we have a shitload of bytes. Oh, I should also note that labels are always null, like null byte terminated. They always have to be. So that's why we have byte 2 and 3. We can actually see only underscore, but there's also a null byte. Okay, so what the heck does it mean? So basically, the first bit, the first byte, sorry, is the length of terminal node. If it's 0, then that means it's not terminal node. In this case, it's a root. We always start with a 0 in the first byte. So we can draw a root. That's basically, this is what would happen if we're parsing it from, like, if we were given a stream of bytes. This is what happens when we actually parse it into a try. So as to, like, regenerate, I guess. Then we get number of branches leaving this node. In this case, it's going to be 1. So that's what we can draw. Then we get the label, which is just the underscore. Now this is the bit that's actually really difficult to generate. So from the try, when you go into the bytes. So this is the offset from the start of the try to the beginning of the node that we're actually pointing at in this edge. It's simple here because we have only one edge. So naturally, it's going to be the next byte. Okay, and again, 0 means that this is a non-terminal node. But in this case, we have actually 2 edges now. So we have mh execute header. And guess what? Now this next bit is, like in the previous case, offset to the node from this branch. So this is hex 21, which is the byte 33. And we will actually do like a, well, it's almost like a recursive call. It's not really, but we're going to actually jump to that byte. And then we're going to parse more information about the next node. And if there is more edges, we're just going to keep descending until we reach a terminal node. And we're going to go one step up and then descend in the next direction and so on and so forth, and until we get the entire try out. So this is like the standard depth first search, I guess. Right, so in this case, as you will see, byte 33, we do have a terminal node because the byte is non-zero. It's actually 2. This points to 2 bytes worth of information. So as you'll see in a minute, so we have a terminal node. Cool. Number of edges leaving it is 0. And the export information, this is the stuff that DYLD needs. So this is the export flags. I'm not going to go into that. Actually, I don't even know what some of them mean yet. There is no docs, obviously. There's only some information in header files, and you have to figure out what the hell. I had a look in LLD. They do have some bits implemented, not all of them yet. So I guess we're just going to exchange information if someone gets somewhere first. And then the important bit here, we also have virtual memory address offset. So the offset is actually from the start of the text section in virtual memory. And for the sake of argument here, assume that MH execute header starts at 0. So basically, it's at 4 GB, offset 0. Okay, so we go back up. We then go to the next label, which is main. And then the offset to the next node is actually 25 in hex, just 37. So the size of that one is 3 bytes. So what that means here is, like, again, byte 38 says that we don't have any children. Oh, but if it's a terminal node, because I'm pretty sure that's going to be one of the questions. If it is a terminal node, you can still have children as well. This would appear probably if you had some a proper full substring of a different string, like, I don't know, _mh or __mh, and then __mh execute header, then you would have two terminal nodes. But anyway, so bytes 13 and 40 is ULIP128 encoded a value for the offset. So it's 18, 20, which basically gives you in hex 1000. So we can expect this symbol, which is main, at 4 GB plus 1000 in hex. Okay, so cool. We got to the end of it. Now let me show you what it actually looks like in real life. And this, unfortunately, is going to be quite boring because we have, as I said, we have only one symbol, and that symbol is start. But we do have, so the next node is actually at the next address. Terminal size is 3 because we have 1 byte for flags, and we have 2 bytes for symbol offset, which is 1000. And if we're going to get back here to the, to that section, you're going to see, yeah, there you go. See, the address is actually here. So that's the start address for start. So that would be it about MachO. I think I did ask if anybody wanted to see if we can actually cross-compile with stage 1 and I think C code from, say, Linux to Mac. And this is actually functional right now, except for the fact that the generated MachO executable misses a couple of things. If there is interest, I can't see the stream, but if you guys want to see it, I can quickly show you this stuff as well. So Loris, is there an interest in that? So basically using the Zig CC to cross-compile C code, say, on Linux to Mac.
Let me see. Okay, we have a yes. I think that if you offer free stuff to people, they're gonna take it, of course.
Cool.
Yeah, okay. There are a lot of yeses. Yes, let's go.
So this is like so yeah, you can feel free to talk here as well. This is like a freebie. This is just something that we like Andrew and myself merged in recently. So I actually managed to dig out the bare minimum set of headers for the libc to actually get it to work. And I'll show you that there is one bit that's broken. I think we could fix it. We could patch it ourselves, but I'm not sure what's better here, whether to wait for LVM to do it, if they'll ever do it, or I don't know, stage 2 or something. But basically, let's go to examples. And this is we are on Linux. Okay. So we have this tiny bit of C here, and we can, so in build bin, Zig have actually the stage 1. Stage 2 cannot compile C just yet, especially with the MachO linker. I'm working on it, but it's not there yet. So we can do this, and this will actually work in the sense that I will compile. Oh, sorry, should be Mac OS. No. Okay, so well, check it out. So this is a MachO executable. It's got those flags, which I'm pretty sure they do signify that there might be a mistake there. So if I will copy it over, out to here, call it this way, why not? Right, so let's just verify that's actually fine. Maybe it's just how Linux actually prints stuff out. Right, Right, you're gonna be greeted with this cool thing. So that's pretty unfortunate, and this actually is not a difficult bit to fix. Actually, I'm not gonna go through this here because it's gonna take us too much time, and then I have to actually get calculator out to calculate the offsets where to insert the load command and stuff. But I'll show you that this isn't too difficult to actually fix by comparing with, oh, I have, right, and I'm on Mac right here. And if I compile it with stage 1 without specifying the targets, I'm actually going to link with the native libc. It will work, obviously. Right, so everything is cool. So now, now let's have a look, quick look, what the difference is. Just to show you guys that actually it shouldn't be too difficult to fix. So where are we? Cross, right. So on the left, we have the executable that actually works. And on the right, we have the one that actually compiled, but doesn't get loaded. So the first thing, if you notice, in this case, we do have this infamous, I guess by now, it's like this unwanted child, everybody, is the lc load dilib. And in this case, we don't. And as far as I remember, this is because LLD, which we actually use in stage 1, to link is not allowing you to actually link or specify that load command without passing in the L system flag, which then actually LLD I think checks runtime whether you are on the Mac. If you're not, then it's going to just trip. Okay, so this is the first bit that's actually missing here, and then the next one, which is pretty obvious, is that if you go into the symbol table, you're going to have a look at the DYLD stub binder. This is the symbol that actually we include in stage 2 as well. And it's pretty easy to include. You have to specify it as the so-called undefined symbol, because this is the symbol that's provided to you by DYLD when your executable is loaded in memory. But all you have to do is basically specify the library ordinal where you would expect to find it. In this case, it's libsystem. So let's give me a second. So that symbol table. If you notice here, we don't have it because we are not specifying the lc load dilib as to link to libsystem bdilib, right? So this is the first thing we would need to fix. So the easy fix would be here to basically just do this. Obviously, we would need to add the lc load dilib and then tweak the Mac 64 header with the additional size, and hopefully we wouldn't actually run out of space and override text section. And then the next thing that's actually missing, and actually, well, two things. If you go into the dynamic loader info, we have binding info, the opcodes, and if you see closely here, again, this should be dilib 1, so that's the data should be 11 is 30 as it was. And then the next thing is in the lazy binding info. Yep. So it's almost there. All we need to do here is actually open a hex editor and add the bit for the lc load dilib, and it would actually work. I can guarantee this because I managed to get it to work like the other day when I was experimenting with the stuff. Okay.
Well, yep.
So a bit of hackery, I guess, towards the end.
Okay. Do you have anything else to demo, or do you want to move to the Q&A?
I think we can move to the Q&A. I think I bored everybody enough as it is. So there's more coming, but you know.
Yeah.
It's like good wine, right? You have to open it, like, breathe and stuff. So.
I see. Okay, so let's open the floor to questions. So if you have a question for Jakub, please either you can write it in Twitch chat. Make sure to add me if you can, at Christoph _T, If you are in Discord, you can also use, I don't know, the voice text channel if you want. Please tag me also in there. This applies both to the Showtime Discord or to the Zig programming language Discord server. And I'm also on IRC. If you are watching, you don't like signing up for accounts on services that you barely use. So if you can't type in Twitch chat, feel free also to send a message in the Zig IRC channel on Freenode. That's fine too. In the meantime, so while people start thinking of questions, Jakub, let me start. So, just well, actually, let me start with, how are you? How are you doing? Tiring times, right? So, how are you holding up?
Good.
Everything is fine.
You know, yeah. Given the time, yeah. It's it's interesting out there, I guess. Let me put it that way. So I guess we just have to work with what we have. So yeah, all good, I guess.
Okay.
Healthy.
Oh yeah, that's good. That's good. So I guess my first question would be: let me make sure I understood correctly. So the prefix tree that the radix tree that is used to store symbols. It's just one. The entire tree is just one. Every node is laid out next to the other, right? Next to the next. So it's one contiguous chunk of memory, and it has references to within that space of memory, right?
Yeah.
Okay, that's interesting. Yeah. So how hard was it to find out all the information that you needed to make stuff work? Like how
it took me a month.
It
took me a month of actually, like going back and forth. So I started doing executable, then I gave up. Then I went back to because the other difficult bit is I think that was one of the questions that was asked later, but I'm gonna get ahead of myself here. The way we organize stuff in the text section is different from everybody else.
Right.
So obviously there is not, like, it's difficult to compare. So the only way you can compare is with something like ELF, or you could with ELF, or I don't know, PE or something like this. But obviously they have different structures, so you can't really compare one-to-one with MachO. And if you were generating from C, or I don't know, from stage 1 Zig, because they use LD or a different linker underneath, you get different results.
Right.
So even reverse engineering was quite difficult because things were not in the same place. And there's no docs, as you said. There is absolutely no docs. I can't believe it. It's like the only docs you have are some bits of sentences. They're not even like full sentences in header files in like different open source projects by Apple. A bit of here, a bit of there. Some good blog posts by people who actually did take the time to actually analyze what the hell is going on, and that's it. So it took me a whole month going back and forth between executable and object file format to get at the bare minimum that actually worked. But when it did, it was cool. Even though it was hacked, like I didn't even have the export try there. I just everything had manually specified, but it was working. So that means I could actually compare against something. So that was good, but it was an entire month of hell, basically.
I see. Awesome. Well, I can tell you from my point of view, I can thank you personally because I'm looking forward to try this stuff on, and I'm one of those lazy people that uses macOS. So thank you very much for for your hard work.
So am I. Yeah. You're welcome.
Okay. So before I start reading questions from people, I see there are already a few. I just wanted to point out one thing. So for the people that aren't aware, Jakub is part of the core team, right? You were invited by Andrew, what was it, a month ago?
Something like this, yeah.
More or less, yeah.
It must have been, yeah.
Yeah, under COVID, like time becomes a relative concept much more than usual.
Very much so, yes.
Yeah, but so congratulations for that.
Thank
Like
you.
people in chat, please clap, slap, something for
Thanks.
for Jakub's initiation. So let's see. Questions. I'm not sure if I understood you correctly, but why are strings in the text section and not in data? That's from Zakus.
Right. So this is the what I mean by string here was the pointer to int. So I'm not sure whether all the strings will be in like organized by like this, but basically, if we have a look here again, this string here, and I'm not an expert in this at all. I'm learning as I go along here. So when we do pointer to int this bit, the hello world, this bit here gets its own text block that we basically refer to back. A text block as in it actually lands in the text segment as a new symbol, and then we refer to it via the also table. This is meant to help with incremental linking, because if we do, so for example, if I do, oh wait, give me a wee sec. So if we had this, or let's do it this way, 15, and if we did, let's do with watch. Oh, and now we see it should work. From that, if we now tweaked it, what's happening inside? Let's say we tweak it to this. The change should be minimal, because we're reusing the data. Obviously, it's quite big here, but it shouldn't be. This should not generate a lot of bits here, because what happens there is we are reusing. I don't know whether we've seen there. We're actually allocating a new symbol, but we should reuse the text block that we already had the string in. So it should be able to grow. And then the other bit is that even if we do this, we basically in the assembly, we basically refer with an address that doesn't really change, which is the address into the global offset table. Like in here, it's, if I switch to virtual addressing, 41008, which is here. That's the data high here. So this potentially should not change, this address, because we always point to this chunk in the global offset table. But what will change in the global offset table, because we know exactly the size, which will always be an address, we can then swap the address in the global offset table to the new symbol. And I'm pretty sure this was happening underneath recompile with a longer string or something. So I think that was one of the main motivations, was that we don't have to, and I'm not sure how we would actually manage that if we had C strings only. I guess we could, yeah, we'd need to actually, if we had C strings, then yeah, okay, so we need to tweak this text block, which then would mean that we probably need to overwrite the entire, well, at least this text block here, or even the entire text section, which is not very ideal, right? In this case, we actually, because we didn't touch the functional code bit here, which is basically print. We didn't actually do anything. Oh, actually, it should be here right now. Yeah. We didn't touch print at all, which means these addresses stay. We always point to the same cell in the global offset table. All we did tweak was the length of the string, which basically needed another symbol in the text segment, which we then append. So in this text block here in print, we don't have to swap the addresses, because we swap them around here in the global offset table. So I guess that's why. So this allows us to actually do smarter incremental linking that was done with compilation units in C and C++, where you have to override the entire like resultant executable. I don't know if it makes sense. Hopefully it does. It's just this like indirection, I guess.
Yes. Well, I think that if Zakus needs further clarification, he'll write another question or.
Yeah, or yeah, you can just ping me on Discord or something, and I'll be happy to explain.
Yeah. So next question: what part of the self-hosted compiler needs the most help / is easiest to get started?
Oh, I don't know. I picked linker, and I was like, oh my god, what I do? So I think every single bit needs that. We have a lot of codegen missing. Would be cool to get into. Oh, I should probably say I'm pretty excited, even though I spent a lot of money on this. I got into the Universal App Quick Start. No, wait, Universal App Quick Start program. I think that's what Apple calls it. So I'm gonna get the Mac Mini with ARM chip in it. So, and this is when I was applying for it, I said I'm only gonna do Zig on it, like development of the Zig compiler and stuff. And they were nice enough to actually say, yeah, that's cool. So I'll be trying to actually get the stuff ported to ARM as well on a macOS, in preparation of for the big day when Apple Silicon comes out.
Nice. Yeah.
So there's obviously ARM is missing. Joachim has been doing some great stuff there, but we miss this. We miss a lot of code in different places. Yeah, a lot of stuff. You basically, I think, can just open source code and just find out to do. in the main source,
yeah,
directory. So
I think maybe another like a recommendation from a social point of view would be to get a hold of Andrew whenever after the 0.7 release and after his more stable situation given recent events, and I think he'll be happy to direct people towards a easier starting point.
Yeah, definitely. That's a very good idea. Yep.
So question by Iridescent Rose. How do you get into developing the compiler? Anything that helped get started?
So once upon a time, and that was ages ago, I read a bit of the Red Dragon book. Quite outdated. It's very outdated even. This helped a bit. I think with Zig, we're in a superb situation because Zig code is very well written. Like all of it, like all the bits are really, really well written, really well thought out. So you're given some, real life examples right there. And if you're not scared of actually experimenting and see how it breaks, with a bit of assembly, I'm not very good with assembly myself. I had to read a lot of the stuff about the opcodes for Intel 8664 when I was doing this stuff, just to figure out what the hell was going on. But this definitely helps. I think we have some really good guys in Discord who can really help out. They know a lot of stuff. And for the linkers, the linkers and loaders, this book is pretty good. Even though it doesn't cover anything for macOS, the general ideas are really good. Oh, the Andrews and Loris's latest blog post on, I think it was like we're leaving a LLVM or something like this. It's really good. It doesn't really go into the technical details, but it's got a lot of stuff like hidden. Like if you read behind the lines, it's got lots of information that can get you going with stage 2.
Yeah, I think that's a good answer. One maybe thought that I can share from my very ignorant point of view. I have to say I have never contributed to the compiler itself. I contributed to the standard library, but I never ventured the compiler. In main part, I guess the main part is ignorance, but the second biggest part is that because it's C++ and I'm not touching C++, but this doesn't apply with the self-hosted compiler, right? And
right.
And one thing that really helped me learn something that I never knew really anything about in my case, which was the event loop, how event loops work. I've been using async await in higher level programming languages like all my professional life, basically. But I knew that the event loop is somehow juggling multiple things at the same time, but how the juggling happens and the curious constraints that you have to respect, or actually that you can even break, with knowledge of how everything works. I never had that, and in my case, what helped me was clone a copy of Zig, got out everything from inside the implementation of the event loop, and start filling in everything back again to make it work with, like, you start with a super simple program, which, by the way, now this is another amazing thing. The beautiful thing of Zig is that lazy evaluation of code allows you to only implement the part of the interface that you actually need to make a code sample compile. So in my case, as long as my test program was simple enough, I didn't even need to care about subsystems, subparts of the event loop that you would otherwise need. So for example, I had a script sample that just opened a TCP connection. So you have to implement the connection part. You don't have to implement maybe a part about files or about other syscalls that can be async. And that's, I think, a superpower that you can probably leverage in certain situations to not dive, but I guess slowly submerge yourself into the problem that you want to solve and understand better. So that's a great feature.
Yeah, that's for sure. And that's actually a good point. Ironically, this actually tripped me up the first time I started doing Zig, because I was expecting the compiler to start shouting at me if I missed something. It turns out I wasn't using it, and it wasn't even compiled. I was like, oh, okay. So, but that's a very good point. Just try and experiment, and there's a lot of very well written code in Zig.
Soapstone,
that's why people are saying that.
Yep.
Sorry, I'm just gonna add that. That's why.
Sorry, please.
That better to look through the test cases and the code itself, because it's kind of self-documenting, right? Obviously, we need higher level documentation as well, but for the meantime, if you want to get deeper into how the things work and where to contribute, if you read the code, then you just, first of all, you're going to learn how to write idiomatic Zig, and second of all, you're going to learn about the bits that you want to tweak from the code itself. So this is pretty cool.
Right. Soapstone was mentioning, I think you answered this already, but just in case you want to expand a bit more. So Soapstone was saying that Rui, the creator of LLD, recommended Soapstone on Twitter the book Linkers and Loaders, the same that you mentioned. So Soapstone was asking if you would recommend it.
Yeah, for sure. I got a copy myself now, like a physical. So yeah, for sure. It's also quite dated, I think. But it's not too long, and it's got a very good perspective on stuff. So it's definitely well worth it. Point of caution here, though, that we are breaking ground here with the self-hosted compiler, because it's so tightly coupled that we are doing stuff in an unorthodox way that I'm pretty sure some of the guys would basically called us for. But hey, if this is the way we can actually approach and achieve hot code reloading and incremental linking, then why not?
Yep. Next question from a root dev. This might be out of scope, but I'm wondering if we know if Zig 0.7 will work out of the box with macOS Big Sur.
Will it? I don't think so. I think we're missing. That's a very good question, actually.
Well, I think the question is not about incremental compilation, right? It's normal Zig.
It isn't, but it can't. Well, it does. Well, it touches upon it, right? A little bit at least. I want to say no. Unfortunately, no. Although I know that Frank Dennis, who goes under the alias of Jedi SCT1, who's been doing some amazing work when it comes to the crypto support in Zig. He did open I think it was him. He opened an issue for Bixer support, and he's got like almost like a manual what you need to add and tweak to make it work. It's not that much. I'd hope. I would hope that we would get support before 0.7 or during the release, but I'm not sure. There is a couple of bits. Plus, we are still with at least stage 1 dependent on LVM. And I'm pretty sure they also struggle as well. So, but we'll see.
Yeah. In any case, I would say my recommendation is if you're somebody in. So I guess the problem is, Jakub touched upon of these problems. Another practical, like human problem, is that the 0.7 releases has a set date, Andrew has to write the changelog, which is a massive task, and these plus other things, like it's not easy. Like there's the practical problem of actually merging the changes, right? So even if we assume that the code is there, there's also the practical problem of merging changes on time with a tight deadline. So if that doesn't happen, it's not the end of the world though, because my recommendation is, if you are invested enough in the Zig ecosystem, stay on master. Like download nightly builds from the website, or clone the repository and compile Zig yourself. It's not hard. If you have trouble with it, join a community, ask people how to do it. People will be happy to help you. So even in that case, don't worry. Don't think of Zig as broken for the next 6 months until the next release happens.
Yep, well said. We'll definitely fix it. So
yeah. Okay, let's move forward. Next question from Suirad. How do you handle large growth of sections? Do you order the sections in a specific way?
Excellent question.
So do you wait, there's the second part. Do you order the sections in a specific way, like have the text section last so it can grow?
Right. So so the idea that's actually an excellent question. And even though I'm going to answer a little bit about this here, I do encourage you to have a look at the actual implementation. And it doesn't really matter whether it's MachO or ELF, for example, because this bit of code should be common to both. So basically, yeah. So and it's, I think, Andrew's brilliant idea. We do have some padding. It's heuristics. It's not. There's no real science behind it, but we do have some padding in the sense that, well, would say we would need the ideal capacity would be some X. We do leave some room to grow within a text block, and the text block is basically the bit that will have, for example, a function, like the machine code for a function within itself, like print, as you saw, or exit or something. And then if we change it, like in an incremental fashion, if we still have some space left, we're just going to reuse this block. So we don't have to grow, we don't have to move anywhere. But if we do, then yeah, basically what we do, we invalidate that symbol, that text block, and then we look for a new one. So we have the logic we have for this is not too, it's not complex. It's quite tricky to get your head around. It's not complex, and it's really cool. So we basically scan the file for the next available offset within for a new text block. However, so this is when it comes to MachO, we cannot grow the text section yet. I didn't add this bit. There is an assert that if this is required, then we're just going to panic because I didn't have time to add that yet. Unfortunately, this is either my lack of understanding of how MachO works, or because MachO is broken in the way it organizes segments and sections. In the sense that when I look for expansion of the text section, I need to bear in mind that it has to be obviously for each segment has to be 4 kilobytes, so the page aligned. But the bad news is for example, if we're going to start overlapping a different segment like data, I cannot just move this segment after, like basically copy all the stuff after data, because text segment has to stay first. So I'll need to wiggle a little bit, in the sense that instead of moving text segment, I'll have to move everything below it to allow for growth. But we'll get to it, right? So, but it's an excellent question, actually.
I have a small follow-up question from that. You mentioned that you leave some wiggle room whenever you allocate something like in the text section and everything else. Is this amount of extra space configurable?
Currently, it isn't. I don't see why we would not have it configurable. I'm pretty sure we would. We also have a couple of hints that we should get from the compiler itself. For example, what the expected program size is, or how many symbols we are expected to receive. Currently, they are hard-coded to some large enough values to actually allow for good experimentation. That's why, actually, can you share the screen?
Sure.
Show my?
It's always showing.
Just for a second. Can you guys see this?
Yes.
Yeah. So this is about the growth in general. So this bit of code is really simple. If we were to compile something similar with LLVM, we would get a really small executable. But what we have here, if you have a look at, hello, you can see that we have 368 kilobytes. And there is actually not much stuff in it. There is more zeros than there is actual code or actual bytes for stuff. And this is because we do pre-allocate a lot of stuff. We basically leave a lot of padding to allow for growth. So for small executables, we do take a penalty in the sense that it's going to be a big executable, relatively speaking. But at the same time, we won't run into the growth problem so quickly, because LLVM, if you play with this yourself, you're going to see that LLD actually generates everything quite compressed. Whereas we do leave padding out, like, or at least at the moment.
Coming
so
in
for
hot.
I made a terrible mistake. Sorry. No, please continue. I made a terrible mistake. I didn't disable text messages. People send TTS. Sorry, text to speech. Anyway, sorry. Please continue.
That's okay. So as I was saying, so for example, with the header and load commands, the way we currently have it in MachO, we leave a lot of padding underneath it until so there is a lot of like zeros between the text section and the load commands. I don't know if you can see this, but the load commands end at 2E0 plus 8 bytes. But we start the text section at 4 kilobytes, right? Which is the so that's what I mean. So basically, I'm still kind of like battling with this. I'm not sure how to do it properly yet. That's my answer here. I actually spent a lot of time drawing stuff on paper when I was doing this, just trying to figure out what the heck. So if anybody's got any ideas, then it'd be cool. I'd be happy to listen to them.
Okay, yeah, I think that, well, this is all as you were saying, like, this is all a new effort. So I'm sure a few things will be. We'll discover them as also people start using and provide feedback on what their experience is. And so I think we got all the questions from Twitch chat. I don't think we have anything elsewhere. I'm not gonna click into the voice channel because I don't want text-to-speech to start making noise again. Somebody should answer the question of why is text-to-speech enabled when you are in streamer mode on Discord. This really boggles my mind. But anyway, sorry, this is my production problems. Like today, I was 2 years old when I discovered that text-to-speech still goes through streamer mode. Anyway,
Soapstone said Loris is mommy.
Jesus. Okay, let's switch to a channel where he can't find me. Holy cow. Sorry, Jakub, you can't hear this, but like I'm making too many mistakes today. production wise. Okay, sorry for keeping you so long in the Q&A. I hope
okay.
it's okay. Okay, I hope it wasn't too stressful. But
No. It was a long presentation, so
yeah.
a long Q&A is expected.
I think people really enjoyed it, and like they had reasonable questions for you. So let me just answer one final question that I think it's more for me than for you, and then I'll give you a moment if you want to say anything else, and we'll move forward. So this question is from Redline. The question is, will there be a Zig release before 1.0 that acts as the, hey, this is pretty much stable, wink, wink release? And the answer, given what I know today, is that maybe to some degree, I would say not exactly with given how I interpret your the part of the question between quotes about this is pretty much stable. I don't think it will be exactly like that. But the plan is, as we approach, as we get closer to 1.0, we will start releasing also minor versions that fix bugs for features that we want to keep stable from the point of view of bugs, not of the interface. So I would say that as long as Zig is going to stay under 1.0, you should expect potentially for the syntax to change always. Not in practice, like you shouldn't expect Zig to be like to revolutionize the syntax completely from one day to the next. But being lower than 1.0 means that if there is reason to do so, we are still going to do it, right? We are not going to prioritize retrocompatibility over fixing bad design decisions. So, but that said, as we move forward, of course, the design will become more and more solid. Just like now, today, you can like your code tends to compile. There are still some changes, but it's not like dramatic. But when it comes to bugs, we will do also minor releases for bugs. So right now, today, if there is a annoying bug in version 0.7, for example, if it ends up being that Big Sur is not supported in version 0.7, that's how it's going to be for the full lifetime of 0.7. But in the future, for example, there's a feature that everybody wants, but it's still not working well yet, which are packed structs. If we decide that packed structs are a feature that we want to support from the point of view of prioritizing bug fixes, we will make minor releases over the current stable version of the language, which might be 0.8, 0.9, and that is closer, I think, to what you are referring to, even though it's not exactly the almost stable release. I don't know when we are going to get there, to be honest. And with that, I would say, Jakub, anything else that you want to add before we move forward?
I think I got everything. So.
Okay. By the way, thank you very much for the presentation. I really appreciate it, as always.
Well,
and
I'm on the hunt. Was it T-shirt after 3 times? No.
Yes, one talk.
Yes, I'm on the hunt for that. Yeah, there you go. Yep.
So yeah. Again, thank you very much. It's been a great pleasure.
Yep. Likewise. Thanks.
Oh. Oops, sorry. I should have unmuted myself. So what I was saying is there's a breakdown. Once we come back, there's going to be a talk from me on the Zig standard library, how to roam the Zig standard library, even though there is no docs for the standard library yet, but can you make do without? I think the answer is yes, and I'm going to show you how to actually do it. So see you in 10 minutes. 1 minute, 20 seconds left. Oh, yes. Get ready. We're going to start on time. We are kind of late also today. Wow, it's already almost midnight. Show is supposed to last less than 2 hours, but I think the presentation from Jakub really spurred a lot of questions, and yeah, it was a while to get through all of them. So if you are tabbed into Crowd, Moon, I don't know what kids watch today. If you're watching Among Us, get ready. Yeah, never too much of a good thing. I agree, Suirant. So let's see if we're gonna be able to do everything correctly. The second half. Okay, let's see. I'll try not to take too much time. So let's see. Beginning of the presentation. No. They should be present to view. No, they should be. Is this it? Yes, that's it. Talk about messing up. Okay, I think we are good now. Finally. So today's talk, reading the Zig standard library, because who needs docs? And the truth is, well, docs are not bad. Kinda having docs would be nice, but right now, we don't really have a proper set of docs for the standard library. So the question is, what do we do in the meantime? And what I want to do is basically give a very, very quick, as quick as I can make it, rundown of all the things, how to get started at looking at the Zig standard library if you don't feel confident in doing this kind of thing. And also run through what I think are like the most common questions that one can have and see how we can answer them by looking at the source code. So yeah, let's get started. So first of all, there's a difference between the language reference and the Zig and the standard library documentation. So Zig has a, I think, also pretty good language reference, which teaches you how to do all the basic stuff with the language. But the language reference teaches you about the language itself, doesn't tell you much about the standard library. Maybe in some examples, some components of the standard library will be used, but that's not the point of the language reference. The language reference teaches you about how to do if branches, for loops, what are the types of variables that you can make, do you need a semicolon at the end of a statement or not, etc., etc. Well, the standard library documentation, it's just documentation of what the standard library is, and the language is a thing on itself, even without the standard library. Even though we normally consider the standard library an important part of the language, it's actually an accessory. So when we talk about the language reference, there is a language reference already available on the Ziglang website. And that's what you're seeing here in the screenshot. It would be nice to be able to show you also the full URL. Unfortunately, it's not possible because Google decided that full URLs are bad. Let's show only domains. We're Apple now. And I don't like this. Also, Google is pushing AMP, which is a corrupted version of HTML. Then there's also a quick, which is another weird thing where they mix up what TLS, TCP usually do, but now they reinvent it on top of UDP. And I mean, if you look at this, it doesn't seem too bad, but then you look at this and you notice that quick is kind of stealing concerns from below and from above and boxing TLS in the meantime, in the middle. And I don't know, but at least you can say, well, at least they're doing this to increase speed, which is nice, right? We want the web to be faster. It's always too slow. Then at the same time, if you open a YouTube page watching a YouTube video downloads the title 14 times to display it twice. Yeah, that's also that. So makes you wonder what's up with Google and the internet. Sorry for this rant. I don't know. I really needed to put this in the slides. Also because I don't know. It kind of feels like, you know, there's the web, there's Java, and then Google comes in and says, "Oh, it's for me, right? This was you made this for me, right?" It's like, no, get your hands off this stuff, please. Also, I'm mentioning Java because, as you might be aware, Google and Java, Google and Oracle are have been heard by the Supreme Court of the United States recently, and was very interesting the things that they said. So Google is doing all these questionable API design work, and I mean Google, I think, is famous for doing questionable design API, and then they have their lawyer go in front of the Supreme Court and argue that APIs, which they define as an interface which is connective tissue between computer programs, which is at the most barely creative. They are in front of the Supreme Court arguing that there is no creativity in designing APIs. How dare you? Anyway, I don't want to push too many bad words into this presentation. So I'll just say that I watched the full presentation, like the full series by Casey Muratori about Google versus Oracle. He's like listening to the entire recording, commenting it, and giving you also input on what they are referring to every time they refer to another case. I think it's a very interesting listen. It's multiple parts. I think it's 4 parts in total, kind of long each part, but it's worth it. If you wonder why an API should or should not be protected by copyright, and what the hell lawyers by Oracle and Google are trying to make the United States Supreme Court do, it's like it's crazy, interesting, crazy, and I think also it's interesting even if you're not interested in like lawyer stuff much. But I think your programmer mind might enjoy it anyway. Anyway, enough of this rant. Let's go back on track. So I can show you the URL, but to reach the language reference documentation, you can go by clicking this beautiful link here, which is attached to every release. So master is the latest version. This is what we usually recommend people use, at least now that Zig is always still evolving. And there's a link to the documentation that you can find, and it tells you a lot of stuff. But it doesn't tell you much about the standard library. So for the standard library, what we would need is to have the Zig Auto doc system working, completely in order. And it is there. It's not completely broken, but it's not complete yet. And I think it's not in a state where you can really rely on it as you would with, I don't know, for example, the auto-generated docs from Rust. So this screenshot is what it looks like, and you might say, well, it kind of looks like the one from Rust a little bit. Yes, it does. I think a lot of the design ideas were kind of stolen from Rust, which I think is a good thing. And these that I'm showing here in particular is the documentation from my Zig OK Redis client. And yeah, it works. I rebuilt this yesterday, and actually no, today, and it still works. It's not bad. Some things are like some symbols are not resolved as they should, etc., etc. And so it's, how can I say? It's not completely broken, and but the problem is that development of the autodocs is kind of stopped until we move forward, until we put the self-hosted compiler in a working state. Because then, like right now, doing more changes to the autodoc system that basically is based on changes to stage 1 is a bit of a waste, in my opinion. So I guess that's one of the reasons why this effort right now is not progressing much. So to give you an idea, though, let's say you want to play with autodocs today. So you have your own small library and you want to try it out. You can do that. And the way it works is that it basically relies on two types of comments, / comments on top of a declaration, and / plus exclamation mark at the top level of a file that basically represents, let's say, a module, a package. And then you just run this command. So let me explain to you why this is Zig test. So you can do emit docs on test or even compile exe, like build exe, or I think even on top of run. But the problem, the idea is, like, if you just want to generate docs, you don't care about the binary. So this is why I have no emit binary. And the reason why I'm testing is because Zig is doing lazy evaluation. So if you have an executable that it's not using everything inside your library, then the things that you don't use are not going to be referenced, and then they won't show up in the generated docs. While the idea is that your test cases should use, well, in general, should use more of your standard library. But more importantly, inside the test case, there is a very useful function inside meta, inside the meta namespace of the standard library, where there is a function called refer all decals, ref all decals, which means basically make sure that every declaration inside this type that I'm giving you is referred to, so that it shows up in the documentation. And usually these calls are put inside test, so that you use test to emit the docs, and then you don't even care about the binary. As I was saying, the autodoc system is still a work in progress. So oh, it's not in std.meta anymore. Oh, it's in std.testing. Thank you, Joachim. Thank you very much. I'm being corrected live. Awesome. So why docs? Why do we need docs? Like, why people want docs for the standard library? And the answer is that because docs tell you stuff, teach you how to do things. They're useful. That said, to be honest, though, especially in the case for Zig, they are not like super necessary, especially when it comes to the standard library. Because as we will see, like, if you think about it, given that the in any case docs would basically be the autodoc system, which relies on comments, you can see these comments in the source code. So maybe is it really necessary? Well, maybe if your code is this, or I just put in this as an example of not perfectly readable code, but I might be thinking about, I don't know, Java docs or some other languages like that. Maybe in that case, reading the source code is way too much. But I think in Zig, you can actually go very far by reading the source code. So autodocs are going to be great when they are complete enough that we decide to really make them the main way of documenting code, but you don't need them, at least for the standard library. Because again, as I was saying, the standard library, maybe it's not perfect, but even if it's not perfect, it's still pretty damn good. And the code, in my opinion, is very readable most of the time. And on top of that, there are doc comments already there. So even if we don't have the nicely generated website with JavaScript that enables fast page transitions and full text search, you can still do a lot of stuff by reading the source code. So, but before we start, let me answer a couple of questions about the standard library. So I'll guide you through really the first steps that you need to take to get used to reading the standard library. So first of all, where's the standard library? And the standard library is inside the Zig repository under lib.std. So you navigate these two folders and you will find the root of the standard library. Then once you get there, how do you navigate it? Well, there is a common structure that basically is repeated for every subpart of the standard library. The main import point of everything is standard.zig. So whenever you do import std, you are importing the public declarations inside std.zig. Then each submodule, each subpart of the standard library has its own file. So for example, if you are doing std, so let's say you imported std, then you do std.math. This refers to what's inside math.zig. Or more precisely, std.math refers to the public symbol math, public declaration math exported by std.zig, but content of that namespace are inside math.zig. These submodules can also have their own folder in case, like some are trivial and only have a file, but some others are not exactly trivial and they have a bunch of stuff inside. And some of their declarations are in the main file, like the implementations are in the main file, but some other more like beefier implementations of, I don't know, types that they export or particularly convoluted functions, they are in separate files inside a folder with the same name. So math has its own math folder. Yeah, it's used when there's a lot of stuff. But the point is, regardless whether there's this folder or not, exports are wired in the main file. So whatever you might find inside the math folder, you will find it first referenced inside math.zig. So this allows you to understand that you don't have to navigate everything, but you have to make sure that the files are the first thing that you check. And to wrap everything, be aware, every export has to flow from wherever the declaration is, maybe inside a file, inside a subfolder, but then it has to flow to its own main file, and then it has to flow into std.zig. So this gives you an idea of how things is organized in a hierarchical way. So while you are roaming the files, let's take a look. Let's see what you have to look for. So first of all, doc comments, of course, because they are giving you a human level explanation of what's going on. Then there are pub declarations. Search for pub declarations, because stuff that isn't pub is something that you cannot access. It's part of an internal API, and maybe you want to learn more about that, but you how can I say? First, you should look for what you are supposed to use, and then if you want to investigate how that thing that you are supposed to use works inside to better understand whether the parameter that you were thinking of giving makes sense or not, is correct, or there are some other preconditions that you need to meet to use the functions correctly. Then you can look into non-pub things. So that's why two important things to search for is pub.fn and pub.const. And by the way, source code in the standard library, unless somebody is being a bad person, but I think every single source code source file in the standard library has been always gets run through zigfmt. So you know it's gonna be you can rely on the fact that it's going to be just one space between pub and fn, and there's not gonna be like weird stuff happening around these particular combinations. So you can search, you can grab through these files. Final thing to look for is tests. I think Jakub also mentioned this in the previous talk. But yeah, take a look at tests, because when you find tests, they show you usage examples. So you don't have to overthink too much and test things blindly too much yourself. When something has a test, that will show you in a practical way how things are supposed to be used. So let's take a stroll through the standard library. And to guide our explanation a little bit, I prepared a series of questions that I'll try to answer, not completely, but I'll try to answer by showing you the relative code, and I hope I'm not going to mess this up, because there's quite a few things that I want to go through, and hopefully I'll be able to do so in a reliable way. So let's see if 3 questions first. So how do I compare to strings? How do I require an allocator? And how do I zero some memory? So let's see how to answer those questions. So there we go. So I'm in the Zig repository. I scroll down, I go into lib, I go into std. And here we go. First, I see the folders because they are put on top. And by the way, I'm doing this on GitHub. You don't have to do it on GitHub, right? You can do it on your computer. But I want to show you that you can even do this by looking on GitHub without having to fork to clone the repository if you don't want to. So folders, but then files. So every folder has an equivalent, a file with the same name. And the starting point is, as I said, of everything. So the sink of every pub thing that you can import is std.zig. So inside std.zig, there are some types. Symbols with an uppercase name are types, like hashmap, array list, hashmap, mutex, packed int array. And these are all imported into std, and these are types that you can use directly thread, for example. But then there's also all the what I refer to as submodules, so all the parts of the standard library, like OS, net, mem, IO, JSON, right? And these are all exported. And here you can see, there you go. You're right, it's testing REFL decals. This is the test that simply makes sure that if you try to build the documentation, every single thing present in here is gonna be referenced so that it shows up in the documentation despite lazy evaluation of code. Okay, so let's try to answer our question. So we had compare to strings. How do I compare to strings? So strings. Comparison of strings is inside mem. Mem has a bunch of things about memory. So there's a declaration. So it's exporting the allocator interface. So I said also another question from earlier was, how do I require an allocator? Well, you import allocator from here and you accept a pointer to this allocator in your functions. So this is where allocator is. But then you would say, well, maybe I'm more interested in seeing what's inside allocator. And you can do that. You can go inside mem/allocator and you will find allocator and you'll be able to look what allocator requires and provides. So there's a validation allocator, which apparently it's a particular implementation of allocator. But let's scroll down very quickly by doing pub fn. So let's see, validation wrap, align, auckland, copy. Oh, this might be interesting. Copy all of source into destination at position 0. So these copies, given two slices of type T, right? It copies from source to destination. And it does the copy, and there are a couple of preconditions that you have to meet to use this correctly. Then there's copy backwards, which has different preconditions. Then set, then zeros. Oh, how do I zero some memory? There you go. There's zeros, allows you to zero any type. But read the documentation here. So generally, Zig users are encouraged to explicitly initialize all fields of a struct. Explicit is written twice. Rather than using this function. So in Zig, you don't zero stuff nilly-willy like you do in maybe other languages. But if you need it, it's here. There's also secure zero. So prevents the store from being optimized out. Next, zero, init, order, less than, equal. There we go. How do I compare to strings? Well, strings in Zig are sequences of bytes, which generally speaking, you can represent with slices, and equal basically compares to slices, and it tells you whether they are equal or not. So we answered basically, I think, all our initial questions, but let's take a look at what else we can find in here. So index of, span, span-z. Span and span-z are a bit advanced, so I'll skip them, but there's len. So this tells you the length of multiple types. And you know you can do slice.len or array.len, but this, I guess, it's also going to tell you the length of like null terminated, or more precisely, sentinel terminated sequences that you don't have the length written anywhere, so you need to scan them. In the sentinels, all equal, dupe, z, so you can see, right, just by searching for pubfn, I can quickly scan through all the things that are offered in here. Let's move into another subpart of the standard library. So let's try to answer some other questions. So how do I get an allocator? Right, I mentioned earlier that mem exports the allocator interface, but what about the implementations of allocator? So where do I get those? And then also, how do I interoperate with malloc? Maybe these are other questions that another question that you might have. So let's try to answer those two questions. So how do I get an allocator, and how do I interoperate with malloc? So let's go back. I know that this stuff is in heap because dynamic memory allocation is heap related, and that's just an arbitrary choice that the standard library made, right? But it's reasonable. So let's see what we have in here. Start from the beginning, and at the top, immediately we have a few pub/const declarations that are exported from something implemented inside the heap subfolder. So in here we have logging allocator, an arena allocator, and general purpose allocator. So this already actually answers how do I get an allocator, and the answer is you can get an allocator directly from std.heap. General purpose allocator is as the name says, is what you should be using normally. Arena allocator is an allocator that implements an arena system. So if you want to know what arena allocators are, there's a talk by Benjamin Feng. You can find it on the Zig SHOWTIME YouTube channel. But long story short, arena allocators, it's a chunk of memory, and you have a program that has a cyclical structure where every cycle you allocate some memory, but then at the beginning of the new cycle, everything that was allocated beforehand, you're not going to need it. Think web servers, think games. Every frame, it's a loop, right? And the arena allocator is very efficient for this type of system because the allocations don't really get allocated in random places in the heap, but there is a chunk of memory that gets used, and you start consuming it. And whenever you reset everything, basically you just reset the counter and keep using the same memory. So that's why it's a thing. Logging allocator, I'm guessing it's an allocator that provides you some logging, but let's go investigate. So inside heap logging allocator, let's see what it looks like. Very briefly, I won't go too much into it, and honestly, I've never even used the logging allocator, but let's take a look at if there's any documentation what it tells us. So this allocator is used in front of another allocator and logs to the provided stream on every call to the allocator. Stream errors are ignored. So you provide a stream like standard error, or maybe a file. A stream is a writer-reader interface, right, on top of a file descriptor of any kind. And then, so you once you have the logging allocator specialized for your stream type, then you can pass it a normal allocator, and every request to the normal allocator gets first routed through this outer allocator that makes sure to print that alloc was called, free was called, shrink was called, expand was called. So yeah, I mean, that's what the name kind of implied, right? So we know how to find allocators. That's nice. No, not even, sorry, heap. So the other question was, how do I interoperate with malloc? Well, let's take a look. There we go. Here there is the pubconst C allocator. So the C allocator is a allocator that, well, it fulfills the normal allocator interface. So you can pass it around to everything that accepts a pointer to an allocator interface, but it uses malloc inside. So to use the C allocator, you have to link against libc, and it calls malloc and, you know, all the usual C standard library, malloc, free, jazz. Why do you want to need this? Well, there are, I guess, a couple of reasons. One is if you are interoperating with a library, with a C library that is giving you pointers to memory that was allocated with malloc, and then you are supposed to take ownership of the memory and free it whenever you are done using it, you need to free memory with the same allocator that it was allocated with. So you can't get this pointer from the C library and then try to deallocate it using an arena allocator. That doesn't work, doesn't make sense. Like the allocation strategy is completely incompatible. But with this, you can interoperate with C more easily. So you get a pointer from C and you free it using the C allocator. Another reason to want to use this is if your program has to play nice with projects where at linking time, like when loading the executable, the implementation for malloc gets swapped out with another similar implementation, like a gmalloc, something like this. So I don't have recent experience with that type of stuff, but some people do, and that's how you do that. So I think we answered both questions. Let's move forward. How do I get standard in, standard out, and standard error? That's another good one. Well, if you watched my last talk, I think you should know. But let's try to answer this again. Standard in, out, and error are in I/O. Inside I/O, there's a bunch of declarations about mode, whether we are doing I/O mode or blocking mode. There's other stuff, but there we go. So look at this, get std out handle. That seems interesting, but it's not public, so we don't care. Then we go, found pub get std out. So this gives you a handle to the standard out, and it returns you a file instance. Standard error returns you a file. Standard in returns a file. And apparently to do, no, async IO on Windows doesn't work yet perfectly. It requires a dedicated thread. So you also learn about this, and there's a link to the relevant issue / pull request in this case. But that's interesting. So there we go. That's how you use this stuff. Are there any tests about this? Let's see. So I haven't showed you any tests yet, but no, it seems there are none. Let's see if, let's go back to mem, or actually, you know what? Let's go back to heap where there were all the allocators. Let's see if there's any test. So test C allocator, there we go. Test C allocator. If we are linking with libc, this test runs, otherwise it doesn't do anything. And here's how you use the C allocator. Well, I mean, in this case, it's kind of obvious, right? You alloc, specify the type, specify how many you want of those, and then you free, it gives you a slice, and then you free it, and then if you want, you can also do realloc. And apparently there's also the wasm page allocator, and this is a test for the internals. Page allocator, heap allocator, arena allocator. So you see, you can use tests to see how to use those. In the case of allocators, they're kind of obvious, I guess, but maybe other stuff isn't. So searching for tests is useful. So let's try to answer more questions now. So we saw that standard in, standard out, and standard error are files. So how do I open normal files, and also what's in a file? So let's try to answer those questions. So files, how do I open a file? Well, I think there are multiple ways. I know one. Maybe chat can tell me what the other main ways are. But if you look inside fs.zig, I believe. So there's a bunch of stuff up here about, so here's file. So file is defined. So one question was how do I open files? And the other is what's inside a file. So file is defined inside fs/file. So we'll go there later. But in the meantime, let's see what else is in here. Max path bytes, base64 encoders. Let's start searching using pubfn. Oh my god, pubfn. Okay. Atomic sync link, update file absolute, copy file absolute. Init of what? Of a atomic file struct. Okay, interesting. Make dir absolute z, so you can, you know, make directories, rename directories and files and stuff. What's this? Oh, this is a directory struct. So the directory struct, I'll scroll down. It's kind of big, has a bunch of things inside of it. So let's see if we can move forward using pub. Next, iterate, close, open file WASI, open file ZW. Z is for non-terminated strings, W is for Windows stuff. And then there's WASI, make dir, make path, real path, blah, 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 a bunch of stuff. Rename. We're not here for this, so let's move forward. Okay, there we go. Here's the entry point. So there's open file absolute. That opens a file giving you, and you have to provide the absolute path. Same with Z for null terminated strings, or for the what the fuck 16 encoding that Windows uses for strings. You can also do create file, but here's what I think is considered the idiomatic way, unless you're trying to do something different. So if you don't have any particular a way of opening a file and just want to open a file based on the current working directory, you just do fs.cwd. This gives you an instance of dir, and then inside dir you can use all these methods to do stuff, but namespace inside the directory, right? So you can do a read file, and you provide the directory, and then you only need to provide the directory name instead of providing the instead of having to like compose and chain strings together and have to think about slashes, etc. So that's I think what is considered the idiomatic way, again, unless you're trying to do something different. So the directory object turns out it's kind of interesting, so you might want to take a look at the public methods that it exposes. Another question was, okay, what's inside file? So once I have a file, what can I do with it? Well, so for file, we need to go inside the fs directory, file, and here we can find the file struct. So it has a bunch of properties. One suggestion is don't look at properties too much. Start by looking at public methods, and the best starting point is init for stuff that has an init function. In the case of files, I think they don't have an init method / function because they are usually they're considered like kind of dumb structs, but they have close. They can check if something is a TTI. So let's start with the public fn dance. So close is a TTI. Does it support ANSI escape codes? Set end position, seek by, seek from hand, seek to, blah, 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 mode. You can start files, right? So to get information about last, when it was modified last, etc., etc. Update times, read to end, read. So you can use this to read a file, but what's more important is, I think we'll find it later, read all. So read reads a bit, but it doesn't necessarily read as much as you wanted to read, while read all makes sure to read everything as much as it can. But there's also, so let's go down, pre, read v, read all. This is kind of advanced stuff. We don't need to look at it. Copy range all, write file all. There we go. This is the interesting stuff. Reader and writer. So dot reader gives you a reader interface. Dot writer gives you a writer interface. I won't go much into detail, but writer and reader are two important interfaces that basically are the generic interface that allows you to print into streams. And I think I'll go back, I'll circle a little bit into this later. But again, look at the advanced Hello World talk that I gave last showtime, a couple of showtimes ago. In that talk, I go more into detail on how these two interfaces work. So let's try to answer another question then. How do I open a connection? Let's see. How do I open a connection? So connection stuff is in net, but again, file first, not the folder. So inside net, there's an address. Let's continue with pub fn. So there's an address, parse IP, resolve IP. So there's a bunch of parsing of addresses, I guess. Equality, IPv4 address. So this is IPv6 stuff, blah, blah, blah. We don't care for now. Connect Unix socket. So if it's a Unix socket and you have a path to it, this is what you should use. So you should use net.connect Unix socket. And look, it returns a file. So we know what a file is, right? And you know that from file, you can get a reader interface or a writer interface to use it as a stream. And there we go. There's also TCP connect to host. So this allows you to connect to a host, but it requires an allocator. Why does it need an allocator? Because to a name can correspond multiple addresses, and that's why it needs to allocate. But if you have the address, so if you don't need to do this step and you don't want to give it an allocator, you just have to make the address instance yourself and then pass it to TCP connect to address. No more allocators required. And you can use also the resolution step of get address list yourself. So this is where you do networking stuff inside net. Nothing surprising here, I guess. Let's move forward to other questions. How do I parse a number and how do I format a string? Let's take a look. So how do I parse a number and format a string? This stuff is inside FMT. Inside FMT, let's go with the pubfn system. So there's format that has a lot of documentation, but I think you shouldn't care much about format because format requires a writer. And when you want to write to a writer, the writer itself exposes a print function that allows you to do a format print inside that writer. So the idea is that the writer represents a stream, so a file, right? You have stdout and you do stdout.writer, and this gives you the writing interface to write to stdout, and the same you can do with a file, for example. And there you will find print, and print will use this the mechanism implemented there. And there's a bunch of format things because format can format multiple different types, and it tries to format them nicely, and so this is all implemented. So let's move forward. Okay, by moving forward, we cross parse int. So parse int is what we were looking for. How do I parse a number? There you go, there's parse int. So it takes a type and then the chunk of text that you want to parse and the radix, and then it parses your int if it succeeds. And here you can see our examples of usage, right? So this wants to parse this string into a U32 and base 10. So this number inside the string is expressed in base 10. Let's see if there are other bases used as an example. No, in this test, all bases are base 10. Oh well. Unless I'm missing something. I don't think I'm missing something. But you can see also that this test is also showing you that if you try to parse -10 into a unsigned number, this returns error.overflow, and this expect error as this. Also, apparently it doesn't like spaces, so you have to be careful about that. So we know how to parse an int. Let's move forward. Parse unsigned. So if you know that something has to be unsigned, you can use parse unsigned. Char to digit, digit to char. Oh, there we go. That's buff print. So how do I format a string? So the idea is, if you want to print to a stream, you should use the writer interface. But if you want to print a string into a buffer and format a bunch of arguments inside of there you go. You have buff print. Basically, you have to provide the buffer. You have to provide the string that you're trying to to format, and the arguments that should be formatted into the string, and then it tries to do it. And another interesting thing is that you know that since you have to provide the memory, otherwise it would have to allocate, it also has to return a slice, because in case it doesn't use all the memory, it has to tell you up to which point it has printed the string and what, and because you know that from there to the end of the buffer, it's garbage data. But it returns an error. Let's take a look at the error. The error is defined here, and there is no space left. Well, yeah, makes sense, right? So if you try to give a buffer that is not big enough to really be able to fit everything, then it has to return an error. So as much as possible was written to the buffer, but it was too small to fit the printed bytes. And so you get this error. And maybe that's fine. Also, think about this. Maybe you just want to print strings in a buffer up to a certain length. Above that, you don't care. And then you ignore the error. So you can reason about these things, about the API, just by looking at the code. It's not too complicated. You don't even have to look too much at the implementation, right? You really can do just with the interface, with the signature and the error. And here you can see that what it's doing is actually using a stream interface that, a stream implementation that gives a streaming interface that is backed by a buffer, and then it's using format to its writer interface. But again, you don't care about this stuff. These are implementation details. So we know how to do buff print, how to do buff print z, count. Oh, and there's also alloc print. So we have buff print, when we provide a buffer. But if you are fine allocating, then there's also alloc print, and alloc print has its own error that it can return, but in this case it's just out of memory, only if the allocation fails. Otherwise it succeeds, because yeah, it can decide how much memory to use. So that's nice. So I think we answered that question too. Is there anything else interesting down here? Oh yeah, comp time print. Comp time print is also interesting. So sometimes you have both the format string and the arguments that are known at compile time. Then you should be allowed to do the formatting at comp time and just have a normal string that gets then turned into the executable, right? And that's what you get from comp time int, and that's nice. And here you have examples of usage, and there's also this set eval branch quota, which I'm not going to get into, but this starts with an @ symbol. That's a built-in, I guess, function. It's a compiler built-in, and you can learn about those from the language reference, but I'm not going to get into that in today's talk. So let's move forward. I think we are almost there. Only a couple of questions to answer. So how do I test stuff? We saw tests, right? But you want to write your own tests. And I mean, you should know by looking at this code and by reading the language reference that a test is just a block. Starts with test, has a name for the test, and inside there, as if it were a function, you write the stuff that should happen during the test. But yeah, maybe you want to assert that something, you want to fail the test if two things are not equal, or you want to do similar stuff. So how do you do? Well, we saw already, right? std.testing.something. So let's go investigate inside testing. What's in there? So inside testing, oh, look, there's pubconst, there's a failing allocator. That's interesting. So you want to test something that takes in an allocator, and you want to make sure that it does work correctly and reports errors correctly. When an allocation fails, boom, use the failing allocator. How does it work? Go open the file, read the documentation in there, and see what the public interface is. But then it's not just that. There's also not only the failing allocator, but there should be also the testing allocator somewhere, I think. So, well, we'll find that later, but let's just scroll down the pubfn stuff. So expect error. So you give it an expression that returns a error union, and then you give it the expected error. And we saw this used earlier, right? And this makes the test fail if the error doesn't. So if the expression didn't return the error that you were expecting. Expect equal expects two things to be equal, but let's see if they say anything about slices. This function is intended to be used only in tests. Yes, I think it's the same for everything in here. When the two values are not equal, prints diagnostics to standard error to show exactly how they are not equal, and then aborts. Nice. Expect within margin. This function is sent, okay, this first part we know, but it's interesting. So this is for like float numbers, I guess. Yeah, the types must be floating point. And there's a margin of error that you're fine with having. And by the way, this is very nice. I'm sure people that have used Go know how sometimes it's annoying that you can't do easily this kind of stuff. But at least I remember encountering this type of problem. So test expect within epsilon, expect equals slices. So this is for slices so that you compare type by type instead of just looking at the two slice pointers. Expect, that's expect for something that is generally, something that should return a Boolean, and the Boolean should be true. Then there's a tempdir thing, so that if you have to make artifacts on disk, you can use tempdir, and I guess, yeah, it has a cleanup method that you just defer the cleanup, so you make sure that the directory disappears at the end of the execution. Oh, and there's a function. So this is the type tempdir, but there's a function. So I guess you call the function with a bunch of options, and then this functions creates the actual path on the file system, and then produces the type at the end. So that's what you should use. Except equals strings and ref all decals. Given a type, reference all declarations inside so that the semantic analyzer sees them, and that's useful also for, mainly I guess, for documentation. So testing has a bunch of interesting stuff in there. Let's go, final few questions. Power, log, etc. So these are math functions, right? Math functions, you probably know by now. And math, there's a bunch of constants that you can find, methods, there we go, ceil, floor, trunk, square root, log, log base 2, so log, log base 2, log base 10, natural log, etc., etc. So they're all here. And if you want to look at the implementation of those, you can go inside the different files. But I just want to point out one thing. These are also mirrored. Most of them are mirrored also as built-ins, but there's a reason why you might want to use the ones in the standard library rather than the built-in. So more precisely, let's find add. So add, you can do plus, right? Like you can do A plus B, but you might want to use math.add because math.add returns overflow as an error instead of panicking in safe release modes, like safe release, release safe and debug, or becoming undefined behavior in release fast. So you can use these to catch the error and decide what to do. And same with all the other stuff. So that's why you might want to prioritize, in certain situations, add over alternative methods. So this answers that, I think. Next, hash map or set. Where are these nice data structures? Or I'm used to dictionaries and Go in Python and Go maps. Where do I get this stuff? And the answer is inside, not hash, but hash map. Inside hash map, there's a few of these things. And actually, let me go back to std.zig. Hash map, we saw those in the beginning, right? Some very important types, you don't even have to import from their own modules because they are referenced directly inside std. So hash map unmanaged, and string hash map and auto hash map are all in here. So let's find out what's the difference between auto hash map. And you see that each one of those has the unmanaged version. Let's ignore the unmanaged version for now. So let's talk about a string hash map, a normal hash map, and a auto hash map. Let's learn what the difference is. And to do that, of course, we go into the corresponding file and we try to find pub fn hash map. General purpose hash table. In order is guaranteed. And any modification invalidates live iterators. It provides fast operations with quite high load factors, blah, blah, blah. For a hash map that can be initialized directly that does not store an allocator field, see hash map unmanaged. So this hash map saves our reference to the allocator inside. The unmanaged version doesn't, but this is a small detail that you normally don't really care much about for simple situations. So this is a normal hash map, but look, it requires you to specify the key type, the value type, a function to hash the key, and a quality function to test whether two keys are the same. And then there's also the max load percentage. So you have to provide a bunch of stuff, like you have to implement your own hashing function and your own equality function. That's annoying. So let's find auto hash map. Auto hash map, it's basically the same thing, but you only specify the key and the value, and it tries to automatically generate a hash function and a equality function based on the type. And you can look into these functions and see what heuristics they use. And the long story short is that basically you want to use this every time for everything except for strings. Because strings in Zig are pointers to sequence of bytes, right? Sequences of bytes. And if you use the most efficient, straightforward way of testing equality of two of these two things is identity, so checking if the pointers are the same. But that's not always what you want, right? Sometimes you are fine with identity, as in the same string, it's the same if the pointers are also the same. Some other times you need another type of equality where you want to actually compare every single byte inside the string. And that's what string map hash map does, because otherwise you might get tripped by the behavior of auto hash map. And you can see that it uses equal string, which does mem.equal, and it also provides its own hashing function. So for long story short, since I think 99% of all hash maps out there are actually string hash maps, use string hash map in that case. Otherwise, auto hash map is there for you. But if you want to get control over the finer details, then you can use hash map directly and fine tune every function and the hashing function itself too. Oh, right. Second question. How do I do a set? Well, I think I answered this already in a couple of other talks, but the answer is that you use hash maps, but you provide the value as type void. So it's a hash map that doesn't store values. And the nice, like in Go, you would use a empty struct, for example, as values. In Zig, it's kind of the same concept, except a bit more elegant, I would say, because when you specify the value as void inside the hash map implementation, the key value tuple, where is it? Let me find. So the entry. Let's find the entry. So pub const entry. So entry has value of type void, and it uses 0 bytes of space. So that's really, really nice. And it basically becomes a set based on a hash map based set without extra overhead. Two final questions. How do I get a linked list? Linked list, it's another data structure that I think is fairly common outside of arrays and hash maps, and linked lists are inside linked list.zig, but I think they're also exported from std directly. So let's take a look. I think we saw them earlier. We have singly linked list, so a linked list with a next, but without a prep, so you can go only one way. And then tail q instead is the doubly linked list implementation. So let's take a look at those very quickly. L linked list, singly linked list. It has a node that contains the data and points to the next node. And let's quickly read the documentation and then maybe see if there are tests and then move forward to the next type. So a singly linked list is headed by a single forward pointer. The elements are singly linked for minimum space and pointer manipulation overhead at the expense of big O of n removal for arbitrary elements. New elements can be added to the list after an existing element, blah, blah, blah. So it's a normal single linked list. And you can see the public methods. And you can see also that they have nice documentation in this case. And there's a nice test that shows you how to use it. Traverse forward, pop first, remove next, and then a bunch of expect. Tail Q. Well, you can quickly see that the node type has a prep and has a next. And this explains the differences, and that's pretty much it. You can scroll down, find tests also for this type and see how they're being used. So that's also nice. And I guess we answered that question too. Final question. What if I want to do multi-threading? Where do I find multi-threading stuff? Well, multi-threading stuff is inside. Well, let's take a look at standard.zig. Do we have threads exposed there? Yes, we do. We have thread. So let's go find thread inside thread.zig. Thread.zig. And in here we have pubconst thread. As I said, don't look at the properties, at the fields of the struct first, but start by the public interface. So I can tell you immediately that thread doesn't have a init function, but it has spawn. So pub fn spawn. This is the function that you use to spawn a new thread. I showed how to do that in a previous talk, which I think it's another thing that I showed in the advanced Hello World talk. But basically, you provide a type that has to be the input type of your function that you want to run in the thread, the function declaration, and then you can spawn a thread, and then it gives you a thread that runs, it's another thread, and then you can, let's see what can you do on a thread. Let's move forward with pubfn. CPU count, get current ID. So you can get the current ID of the, like a unique ID for the, well, not unique, but you know, the ID of the calling thread. You can get a handle to it. You can wait. So wait is what synchronizes with a running thread. And that's it, basically. So these are the things that you can do with thread. So there you go. That's how you run threads. By the way, people should, like, veterans should see that I think this pawn interface is not the best, because basically if you want to pass a single argument to start function, like if you just need, I don't know, a string, you can say that this type is a slice of constant U8, and you pass that, and then that's fine. That's one, and then you give a start function that takes in a string, and that's it. But if you want to pass multiple types, you have to come up with a type that you define here, and then you pass in here. While if this, and you can see that I think this API was designed before tuples became a thing, because I think in newer Zig, what you want to do is this be any type, but then you say here that you don't want start function to be type of this. You want start function to basically have how many arguments it wants, but they have to match what's inside this, inside the tuple that you're giving. And so just use tuple and use you know, the add call syntax to flat. So basically to use multiple, like a sequence of arguments, the tuple, as separate arguments in the function call. Anyway, this is a small detail about an API that I think should be renewed given the new features that we have in the language. So that's how you do multi-threading. And I think with that, I don't have any more things that I want to cover. This has been an hour-long talk. I apologize to everyone for the super long showtime today. And yeah, that's it for today. So let me conclude just with one thing. Since I started ranting about Google, let me finish ranting about Google. So hi, Google. Since Google has been into trouble for using the Java SE standard library, and maybe Google is shopping for a new standard library right now, well, I'll let you know that you can copy this standard library. And also, as somebody that doesn't like Java on their phone, maybe next time no Java, okay? So please feel free to take inspiration. And that's pretty much from me. So that's the end. If there are any questions, I'll give people a couple of minutes as I catch my breath, and then we can move to the end of the show. Fuchsia. Oh yeah, Fuchsia. Is there no Java in Fuchsia? I hope so. I hope. Well, I don't want the JVM in my stuff, but more importantly, I hope so for Google, because if they keep using the standard library from Java even there, oh man, they're gonna pay so much. I don't think so. Okay, that's nice. That's good for Google. Let me drink a bit of Coke. I think they wanted to replace it with Flutter. Flutter, I think it's a GUI library, right? So they would have also to replace a bunch of other subsystems that are based on Java, I think. Fuchsia will support the entire Android runtime and running Android apps. So it has Java. It has to have Java inside. Oh man, they're gonna get burned so much by the Supreme Court, I suspect. Not good for them. Divine retribution, what can I say? Okay then, so since we have used so much time, let's I think we can call it a day here. Let me give you some spoilers. So next showtime, we're going to have two interesting talks. One is going to tell you about crypto by somebody that kind of knows about crypto. We mentioned this person already today. It's Frank, Jedi Sector 1. And the second talk should be by me about built-ins. So today I covered the standard library, but I didn't cover built-ins. I'll do built-ins. I avoided crypto for obvious reasons, right, today. But I'm sure that considering that Frank has contributed, I think, most of the stuff in there, at the very least, a good chunk of the stuff in there, I'm sure he'll be absolutely the most qualified person to talk about it. I'll stick to built-ins. Easier presentation, hopefully. So with that, I think that's the end. So thank you everyone for watching, and catch you next time.
This is how we